In this video, we're going to be looking at sample spaces for independent events. Now, sample spaces are used for two or more experiments when they occur and their outcomes are combined together. Independent events then, so this is when the probability of one event has no effect on the outcome of another event. So let's say if you flip two coins, the probability of a head on one coin will have no effect on the probability of a heads or tails on the other coin. Successive events then, this is when two or more events occurring in succession, so one after another. So for sample spaces, we're going to be looking at two-way tables, and this is always used for two experiments combined. Tree diagrams then, this can be for two as well, but also if it's more than two experiments, we'd use tree diagrams, with each branch having an option. So if you look here, we have a fair coin and a dice are thrown at the same time. List all the possible outcomes using a two-way table and a tree diagram. So first, let's look at the two-way table. So it looks like this. We have the heads and tails on top for the coin. Then the dice with the 6 options here. So like heads 1, heads 2, heads 3, and so on. So we can see we have 12 options. And we know from our product rule for counting, because there's 2 possibilities with the coin, and then 6 with the dice, so 12 outcomes. Then all the outcomes here are listed. Now let's see how this would look with a tree diagram. Okay, so here we are. So you have heads or tails. So you can see how you're branching out. And then we have 6 options coming from the heads, 6 options coming from the tails. So you have a start, we heads or tails, and then from there, 6 possibilities for each. Then again, here are 12 options. Okay, let's have a look how this looks at probability. So we have a fair coin and dice are thrown at the same time. We need to draw a two-way table to show all the possible outcomes, and then a few probability questions. Okay, so here's our two-way table. So let's see now the probability of getting a head on a 5. So that's this one here. So there's one option for that, so that'll be 1 out of 12. A tail and an odd number. Okay, so all the tails are here, so we have 6 possibilities for tails, but then an odd number, so we can have 1, 3, and 5. So we have 3 over 12, which could simplify to 1 over 4. Now, next one then, we have a head or an even number. So we have 6 possibilities for our heads, but then even, we have 2, 4, and 6. So again, 3 out of 12. So 1 over 4. Then a tail or a number less than 3. So for a tail, we have 6 possibilities, or else any number less than 3. So then we'll be looking at the 1 and the 2 from the heads. So we're going to have 6 plus 2 is 8, so 8 over 12, which will simplify then to 2 over 3. Okay, let's have a look at this question here. So 2 fair dice are thrown at the same time and their scores are added together. Draw a two-way table listing all the possible outcomes. Okay, so let's draw that out. So here are all our options. So you can see how they're being added together. So like 1 plus 1, 2. 1 plus 2 is 3. If let's say we did 3 and 3, that gets us 6. 6 and 6 is 12. So you can see these are all our outcomes. So you're adding all the ones from one dice to the other. Okay, now for part A, what is the total amount of outcomes? So if we have 6 outcomes for dice 1, 6 outcomes for dice 2, easy way to do this, we're just going to do 6 times 6, which is 36. Alternatively, I could have added all of these, but that will take me all day, so a lot easier just to do 6 times 6. Now, what's the probability of getting a 6? So let's have a look. 1, 2, 3, 4, 5. So then we'll have 5 out of 36. Next one then, probability of getting a 5. So we have 1, 2, 3, and 4. So we'll have 4 over 36, which could simplify to 1 over 9. Now the probability of getting an even number. Okay, so we have 36 possibilities. So that means that half have to be odd, half have to be even. So straight away there, we'll have 18 over 36, which will simplify to a half. Same for the odd, so 18 over 36, which will simplify to a half. Okay, let's have a look at one more. So in this one now, we're going to be using a tree diagram. So we have a spinner from numbers 1 to 5 is spun and a fair coin is flipped. And we need to use a tree diagram to list all the possible outcomes. Okay, so straight away now, so 1 to 5. So we have the spinner. Okay, so we have 1, 2, 3, 4, and 5. Okay, now we're going with the coin. So with a coin, you can only have heads or tails. So heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. So you can see how two branches are coming out from each number, because this is the one for the coin. Okay, so we have 5 possibilities for the spinner, 2 possibilities for the coin, so we're going to have 10 possible outcomes. So you can see on the right here, I've listed all the possible outcomes. So let's have a look at the probability questions now. So the first one there, the probability of getting a heads and a 4. So a heads and a 4 was here. So only one possibility, so 1 out of 10. Next one then, a tails and a 5. So again, only one possibility there. So tails and 5. So 1 over 10. Now a heads and an even number. Okay, so heads and an even number. So we have 1, 2. Okay, so that is only 2 possibilities. We can have a heads and 2 or a heads and 4. So that is going to be 2 out of 10, which can simplify to a fifth. Next one then, so the probability of a tails and an odd number. So tails and 1, tails and 3, and tails and 5. Okay, so we have 3 possibilities there, tails and 5, tails and 3, and tails and 1. So that is going to be 3 out of 10. And that's it. Any questions, please leave in the comments. Thank you.